Hello everyone, how are you? Today we will move for the concept of energy. What is energy? Energy is the capability or capacity to do work. So when we can do a work, we can say that we possess energy. So what are the different types of energy we deal with in our daily life? When you look at a bulb or a fan, we know that electrical energy is getting expended. So what are the other types of energy? Nuclear energy. When we clap, we know that it is sound energy. Kinetic energy, potential energy. There are a lot of energy terms in our daily life. For a particular system or a body, we deal with mechanical energy of a body. So we are focusing on mechanical energy of a body in this chapter. So what do you mean by mechanical energy? Mechanical energy of a body is the sum total of its kinetic energy and potential energy. So mechanical energy of a body equal to its kinetic energy plus potential energy. So these two terms we will deal it separately in the next coming classes. So, energy. We know that as it is the capability of doing work. Can you think what is the unit of energy? The unit of energy is same as the unit of work. So, the unit of energy is joule. We know that it is abbreviated as J and it is given in order to honor the scientist James Prescott Joule. In certain cases, we use this joule as megajoule, microjoule, etc. So, megajoule means 10 raised to 6 joule. So, 1 megajoule is equal to 10 raised to 6 joule. That means 1 followed by 6 zeros is a higher unit of energy. Then we can deal with 1 kilojoule. What do you mean by the word kilo? It is 10 raised to 3. So 1 kilojoule is equal to 10 raised to 3 joules. These are the higher units of energy that we can use in our daily life. Next, we will deal with the concept of kinetic energy. So what do you mean by kinetic energy? Look at this term kinetic. The word kinetic is derived from a Greek word called kinema. Kinema means motion. So kinetic energy is the energy possessed by a body due to the virtue of its motion. So all moving bodies possess kinetic energy. So an arrow moving, an aeroplane moving, a car accelerating, these are all examples of bodies possessing kinetic energy. So once again, what do you mean by kinetic energy? Kinetic energy is the energy possessed by a body due to its motion. So we know that this is a type of energy. The kinetic energy is also having a unit, joule. Now, we will study what are the factors on which kinetic energy depends on. For studying it, we have to derive the expression for kinetic energy. So this can be a 3-mark question for your examination. So listen children, suppose a body was moving with a velocity u. So that was its initial velocity. So on that body, we applied a force F so that it gets displaced through a distance d, and as we have pushed the body, as a force is applied, you know that there is an increase in velocity of that particular body, so that its velocity increased and it reached here and the velocity increased to v. So u was its initial velocity and v is its final velocity. So the force has done some work as there is a displacement in this body. So listen children, we are going to calculate this work done. We are expending some energy to do this work done. So work done is equal to force into displacement. So we know that as the velocity of the body has changed from u to v, it has been automatically accelerated. So W is equal to F into D. And how can we write this displacement in terms of U, V and D? In the first chapter, motion, we have already studied that the displacement d of a body is equal to v square minus u square by 2a. In that chapter, you have probably studied this d as s, the displacement. Here the same displacement is marked here as d. So, we know that the displacement is v square minus u square by 2a. So, here the work done is F into D, that is F into, we are going to replace this D as V square minus U square by 2A. Suppose that the body was having a mass M. So, what is it? If the body was having a mass M and it was getting accelerated, so how can we write this force according to Newton's second law of motion? This F can be written as M into A. So, what is it children? M into A into V square minus U square by 2A. So, we can see that this A and A get cancelled and we get a final relation for this work as half into, there is a half here, 1 by 2 into M into V square minus U square. So this can be written as half mv square minus half mu square. So this is the work done on the body, and we know that while we do this work, we are expending our muscular energy. So where does this energy go? This muscular energy is converted as the kinetic energy of the body. Suppose we are taking a special case in which the body was at rest. So we say that the body was at rest. At rest, initially the body was at rest. So initially at rest, when the body was at rest, u is equal to 0. So what happens? Its velocity u is 0 and its velocity changed to v. So what this w is equal to? So this w is equal to half mv square, because half u is equal to 0, this term gets 0. So w is equal to half mv square. So we know that this whole work is converted or transferred to the body, as energy cannot be created or destroyed. So we know that the work done half mv square for on a body at rest. This work is converted as the kinetic energy of the body when its velocity changes from 0 to v. So this work is stored as the kinetic energy of the body, stored as the kinetic energy of the body. So what we can write? The kinetic energy of the body is given by equal to the work done. So what is it? The kinetic energy of the body is equal to half mv square. So this is the expression for kinetic energy of a body. And what are the factors on which this kinetic energy depends on? It depends upon the mass of the body. It depends upon the square of its velocity. So what are the factors on which kinetic energy depends on? The factors on which kinetic energy depends on is mass of the body and the velocity of the body. That's all for today's class. We will come with more numericals for this kinetic energy. Thank you.